We're on problem 81. 81, and let's see. They give us this equation. Y is equal to 248 minus 398x. Say, which of the following values of x gives the greatest value of y in the equation above? Which of the... Okay, so we're going to get as large a possible y. Let's see, y is 248 minus this thing. Minus this thing, right? So what we want to do is, since we're subtracting this from 248, we want to minimize this, right? As small as this can be. And even if we can make what we're subtracting negative, that'd be awesome, because then when you subtract a negative, then that'll get us above 248. And actually, if we look at all of the choices, they have one negative number there. You know, you might say, oh, if we put a 0 here, then y is going to be 248. But what if we actually put a negative number in for x? And they have as choice E, -1. What happens when we put -1 there? Then y is equal to 248 minus -1 times 398. So it's minus -398, which is the same thing as plus 398. So that's actually the maximum point, because we're subtracting a negative. Right? That's even better than subtracting 0. And it's way better than subtracting a positive if we're trying to maximize y. So the choice is E. 82. Machine A produces bolts at a uniform rate of 120 bolts every 40 seconds. Every 40 seconds. So that's the same as, 120 bolts every 40 seconds is the same thing as 3 bolts per second, right? Yeah, that's right. And machine B, okay, that's A. Let me write that down. That's A. Machine B produces bolts at a uniform rate of, so this is B, of 100 bolts every 20 seconds. 20 seconds. Well, that's equal to 5 bolts per second. If the two machines run simultaneously, how many seconds will it take for them to produce a total of 200 volts? So if you're running simultaneously, what's your speed per second? This one's going to do 3 per second. This one's going to do 5 per second. So if they run simultaneously, you're going to be producing 8 per second. 3 plus 5. So 8 volts per second is their combined rate. And we want to know how many seconds will it take to do 200 volts. So we just take 200 volts divided by 8 seconds. Right? Another way, with distance, you're used to distance is equal to rate times time. I guess you could view this as, production is equal to rate times time, right? Normally rate is how fast you're moving per second. Now it's how much you're producing per second. And so your total production is going to be your rate times time. And then your time is going to be the production divided by the rate. But I think sometimes when you think too much in terms of formulas, you lose the intuition. But I just wanted to show you that there is a formula for it if you need one. But the easiest way to think of it, well, I have to produce 200 volts. If I said I produce 100 every second, it's like, oh, it'll take me 2 seconds. So if I have to produce 8 every second, I take 200 divided by 8. So 200 divided by 8, and I could even do the units. 200 volts divided by 8 volts per second. That's equal to 200 over 8 times volts times, if this is in the denominator, you just inverse it when you go out. Seconds per volt, the volts cancel out. So you know you got the units right. So to some degree, that should give you conviction that you got the formula right. And 200 divided by 8 is 25. Right? So it's 25 seconds. Is choice B. Problem 83. Problem 83. What is the decimal equivalent of 1/5 to the 5th power? 1/5 to the 5th power. So let's think about this. Let's write 1/5 as a decimal. That's 0.2. So it's 0.2 to the 5th power. So let's just multiply it out. 0.2 times 0.2 is equal to what? 2 times 2, and then we have 2 digits behind the decimal, so it's 0.04. And then you multiply that times 0.2 times 0.2. 2 times 4 is 8, and now we have 3 numbers behind the decimal point. That's going to be equal to 0.08. Sorry, 008. Right? 1, 2, 3. 3 numbers behind the decimal. So this is 2 to the 3rd. And then 0.008 times 0.2. Let me write. This is to the 3rd power. That's equal to 2 times 8 is 16. And then how many numbers do we have behind the decimal point? 1, 2, 3, 4. So we're going to have 0.12 3, 4. So that's to the 4th power. And we have 1 left. So 0.0016 times 0.2 is equal to 2 times 16 is 32. And now we have 1, 2, 3, 4, 5 numbers behind the decimal point. So 1, 2, 3, 4, 5. And that's the answer. And that is choice A. Choice A. Another way, actually the easiest way to think about it is, without having to even do this, you could have said, oh, what's 2 to the 5th power? 2 to the 5th power is 32, right? And actually that alone, because there's only one choice that even has a 32 behind the decimal point. And you could say, oh, and every time I take to a power, I'm adding 1 digit behind the decimal point. So it's going to be 32, but it's going to have 5 numbers behind the decimal point. So 1, 2, 3, 4, 5. I did it the slow way. Next question, 84. 84. 90 minus 8 times 20. I'll write it the way they did. 20 divided by 4. All of that over 1/2. This is just a fast simplification problem. That becomes 90 minus, what's 20 divided by 4? 20 divided by 4 is 5. 5 times 8 is 40. All of that over 1/2. That becomes 50 over 1/2, which is the same thing as 50 times 2 over 1, which is equal to 100. That's choice C. That's just one you just have to do quickly and not make a careless mistake. I hope I did it quickly. I don't know if I did a careless mistake. Let's see. 85. A dealer originally bought 100 identical batteries at a total cost of Q dollars. So Q is equal to 100 batteries. If each battery was sold at 50% above the original cost, so B is the cost that each battery was sold at. So B is going to be 50% above the original cost. So it's going to be 1.5 times the original cost, right? This is 50% above the original cost per battery. Then in terms of Q, for how many dollars was each battery sold? Oh, they just threw us, let's see. A dealer originally bought 100 identical batteries at a total cost of Q dollars. If each battery was sold, oh, I'm sorry. So this is the cost, right? So Q is equal to 100 times what the dealer paid for it, right? A dealer originally bought 100 identical batteries at a total cost of Q dollars, right? If each battery was sold at 50% above the original cost per battery, so the selling price, this is the original cost, is equal to 1.5 times the cost. In terms of Q, for how many dollars was each battery sold? So let's write Q in terms of the cost. So cost is equal to Q divided by 100. Just divided both sides of that equation by 100. And then we could just substitute C, or the cost here, for here. The selling price is 150% of this. So selling price is equal to 1.5 times C, which is Q over 100. Q over 100. And let's see how they did it. So selling price is equal to 1.5 Q over 100. I don't expect to see that as a choice, but if we multiply the top and the bottom by 2, that equals 3Q over 200. 3Q over 200, that's choice A. Gotta make sure you get your variables right in that one. Problem 86. In an increasing sequence of 10 consecutive integers, the sum of the first 5 integers is 560. What is the sum of the last 5 integers in the sequence? Okay, 10 consecutive integers. So x plus 1 plus x plus, let me write it this way, x plus 1 plus x plus 2. Well, actually, the first one, let's call it x. X plus 3, x plus 4. Right? These are the first, this right here is going to be the first 5 consecutive integers if we start at x, right? When you take the sum of those, the sum of those, let's see, it's 1, 2, 3, 4, 5x. 5x. And see, 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 5x plus 10 is going to be equal to, they tell us it's equal to 560. Fair enough. Or we could say 5x is equal to 550. I think we can use that information. Now, what is the next 5 integers going to be? It's going to be x plus 5, x plus 6, x plus 7, x plus 8, and x plus 9, right? These are 5. And what do those add up to be? That's 5x plus 5 plus 6 is 11, plus 7 is 18, plus 8 is 26, plus 9. 26 plus 9 is 35. So that's 5x plus 35. And they want to know what this is equal to, right? That's the next 5. Well, we know that what 5x is. It's equal to 550 from this setup. So it's going to be equal to 550 plus 35, which is equal to 35 plus 550, which is 585. 585, that's choice A. And the trick here to being able to do it fast is just to recognize that you didn't have to solve all the way for x, that you could reuse this 5x when you took the sum of the next 5. And I'm all out of time. See you in the next video.